Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is multi-channel test automation with open source. Our guest speaker today is Avinash Tiwari, Vice President Delivery at Crestek Software Systems. Avinash has vast experience in test automation planning, strategic consulting, and implementation of test automation frameworks. He leads the technology group at Crestek and primarily holds responsibility of managing technology initiatives for the automation consulting practice. He has managed and executed business-critical testing assignments, which includes automation framework implementation, creation and execution of QA and testing processes, creation of test strategies and test plans, and execution of various phases of testing. Avinash has been involved in the implementation of Testing Center of Excellence across multiple Fortune 500 clients. So without further delay, I introduce you all to our guest speaker. Over to you, Avinash.
Thanks, Mohini. So hello, everyone. And at the outset, let me thank everyone for registering for this topic in such huge numbers. And as Mohini mentioned, my name is Avinash, and I'm part of Crestek Software System. A bit about Crestek. It is one of the leading solution provider in this space of independent testing and quality assurance. As part of portfolio, we also have products in the space of test automation, performance, and security testing. I'm currently working in the capacity of VP delivery, as well as I am leading some of the technology initiatives around in the area of test automation and framework development. So without delaying further, what are we in for today? So well, today I'm going to screen for you is a Superman movie full of thrill and action. Did I say just movie? Don't worry, we are here for technical session. I got a bit carried away by the images, Superman images that are present on the screen, but it's definitely loaded with a lot of action. So to set the agenda, though it was purely accidental that I mentioned I'll be screening movie instead of webinar, but I'll keep my words and at least share the synopsis of the movie with you. And hopefully that will also set the agenda for this webinar. So the time in this whole movie story that I'm talking about is around 2010, 2012. And the location is Planet Open Source. And specifically the planet where the open source test automation tools reside. Now, in this period, everyone was living peacefully, be it the world of SOAP-UI, Water, or Selenium, and no one interfered with each other. Everything was going fine, only till the time it was attacked by aliens. So who were these aliens? They were the new age, rich internet applications and other multi-platform, complex enterprise applications. And why were these aliens so powerful? And what happened once they arrived at the scene? They started creating problems. Some of the problems specifically with rich internet applications, that a simple screen also will have part of web, images, video, flash, everything together. So to test that kind of problem, to test that kind of scenario, some of the individual tools became powerless, or individual supermen became powerless, if I can say so. In case of other complex applications, multi-platform complex applications. These applications spanned across platforms, starting from mobile to desktop, databases, web services, etc. I mean, you name it and they had it. What was the impact? Individually, these supermen became totally powerless. The question is, can they come together and become a superpower to fight the challenge? And that's really the climax of the movie. So they needed a superpower which can bring them together to fight the challenge that we just mentioned, challenge of the new age aliens. So today's session is all about how to create this superpower where we can combine the individual capabilities and create a bigger and end-to-end capability to handle some of the challenges that we just discussed as part of this short story. So enough of movie and story. Let's come back to our techies world. What we just discussed in form of movie synopsis, let's try to understand it in terms of some real facts, figures, and situations. In terms of facts and figures, I'm sure you all would be aware of the increasing trend of open source adoption in organizations. And just to validate it, I mean, there are 1.5 million registered users on opensourcetesting.org. Selenium is one of the most downloaded tool in the current situation as far as test automation tools are concerned. But another fact is no tool, especially in open source world, has the capability to automate across multiple platforms. So Selenium is good with cross-browser testing but has no support for image verification, web service calls, or native mobile application testing. There are other limitations as well. For example, it cannot automate any desktop component. It's only for web. Another important fact is, though we have tools available for specialized capabilities, there are no platforms, frameworks, or solutions available which allows leveraging the best of capabilities of these open source tools. So we know that open source world has moved very fast and there are very good specialized tools to handle specific problems, but there are no umbrella-like solution which can bring the best of capabilities under one umbrella, and the user would be able to leverage best of capabilities. With this, let's try to validate what we discussed with some examples, and I'll discuss some of the common open source automation tools that are prevalent in industry these days. So as you can see in the screen, I have mentioned few of the common automation tools which are used in current scenarios. For example, Selenium is one of the common tools, Sahi, Water, Auto8, Sikuli, FlexMonkey. There are few more, but these are few of the most common tools. So with these tools, there are certain limitations, especially in the context of the problems that we discussed as part of our story. What are those limitations? And most of the tools that I have mentioned here are only for web. And if your test case requires interaction with any desktop or Windows component, then these tools are not good enough. In the whole list, Auto8 is one of the tools that can be used. So which means if you have a scenario like that, you need a power to combine Selenium with Auto8. Another example is, let's say if you have your test case which requires heavy image comparison, and these days the rich internet applications. There are controls, there are images, there are videos on the page, which can only be validated by a good image comparison tool or image comparison utility. Most of the tools lack that. So you'd like to use a specialized tool, which is Sikuli, which is one of the best tools as far as image comparison is concerned in the open source world. Another example is if your application or test case requires validation of Flex and Flash component. Now this currently can be handled by a specialized tool like FlexMonkey. So if your base tool is Selenium, you'll have to integrate Selenium with FlexMonkey to handle that kind of scenario. Another interesting challenge that we face, especially with a tool like Selenium. Selenium does not have a very good support with IE. IE executions are damn slow compared to Mozilla or Chrome. So do I have the leverage to run my tests on IE with Water and then run the same script on Mozilla and Firefox with Selenium so that I can use the best of capability of these tools? Currently the answer would be no. If you are using a base framework on top of Selenium or any other specific tool, you won't be able to achieve this. The same problem exists if you are talking about mobile automation space. Again, I have mentioned some of the common tools that are used in current scenarios. These are mostly from open source world. And these tools also have a similar kind of limitation. None of the tools support all platforms. Few are good for Android, few are good for iOS. There are very few for other platforms like Windows 8 or BlackBerry, etc. So it's a tester's nightmare to work with so many tools, where you have to just automate one test case, which should be able, and you should be able to run that test case on multiple mobile platforms. Currently, it can only be done by creating multiple scripts by utilizing multiple tool sets. So you have a similar kind of limitation in the mobile space as well. So coming back to the business problem that we discussed as part of the story, I would like to take a relook at that problem again and see what are the challenges. So what I am talking about right now is real example from a social news broadcasting application. Now, as you can see in the diagram, this application is multi-platform. To elaborate it, this application has multiple kind of end users. Some of the users can access the application from web. People who have access to mobile or tablets can access the application from respective mobile devices. There are users like news editors who has a desktop-based interface. Then this application interacts in real time with popular social applications like Facebook or Twitter, and they send feed to those applications and then also receive feeds from these social media applications. So as you can see, there are multiple, one is that the application that I'm mentioning is multi-platform, plus there are multiple level of integrations involved. And what you see in the diagram is one real example of a business process that needs to be tested. And there are multiple business processes like this. So if I can elaborate this business process, it starts with a mobile where an end user uploads a news video. It goes to editor for approval, and editor has to log into the desktop interface and then approve the item. Once the item is approved, it gets stored in a central database from where it gets published to web. So end user who are logging to the web application or web portal can see the published news content, and at the same time the news content gets feed from the Facebook. So all the likes that are happening, some of the comments that gets posted on Facebook also gets reflected on the web portal. So the test case starts from a mobile platform, it goes to desktop, there is database verification involved, then you need to go and verify on the web, and finally you need to verify a few things by calling web services for the integration of other applications. So based on what we have seen so far, it's quite clear that there is a need. So there are no tools available in the market, especially in open source world, which can handle this business process. If we have to automate this application or automate this business process, what would be the way? I'll have to automate the mobile with a mobile tool like Robotium or Appium, depending on the choice. Then desktop can be automated by Autoit probably. For database, you can use your own VB script, JavaScript, or SQL scripts. Web can be automated through Selenium or Water or Sahi. Web service again can be automated either through pure Java functions, or if there are complex web services, these can be automated through SOAP UI. So as you can see, we require multiple tools together to test this one common business process. So based on what we have seen so far, it's quite clear that there is a need for a platform which can bring multiple tools together and allows you to use specialized capability of a specific tool and still abstracts the user from learning multiple tools. So three things basically: bringing in multiple tools together, allowing the specialized capability of the specific tools, and abstracting the user from interacting directly with the tool. So you need to, what I'm talking about is a common platform for interaction with all the tools at the backend, so that user need not know the tools in detail. The question is, how do we create such a solution? Is it really possible? And if it's possible, what could be a way? What could be a possible architecture? What could be a possible design around it? Following that, I'll also be discussing some of the existing solutions, and I'll also showcase a real implementation of this kind of solution. So before we look into the architectural or design aspect of a solution like this, there are some key points that we need to consider. What are those key points? The first is that this kind of solution has to be tool and technology agnostic, which means we are trying to bring multiple tools together. So this platform needs to be completely tool independent. So today, let's say maybe you are integrating 3 tools, 4 tools, but it has to be scalable enough to integrate more tools in future. So it has to be completely tool and technology agnostic. End user abstraction. As I said earlier, also, if you are integrating multiple tools, user would like to have a common interface to interact with all the tools. Otherwise, it becomes quite cumbersome, and the solution will not be scalable for sure. If we have to make sure that the solution is acceptable to a large section of users, there has to be some kind of abstraction and a common platform provided to users for interaction with various tools. And finally, scalable, extensible, and adaptable, which means the solution should be flexible enough to integrate more tools if required, because we are talking about specialized capabilities, utilizing specialized capabilities, and if tomorrow there is a new tool which serves a specific purpose, I should be able to use that tool without much of an hassle. So the solution has to be scalable and extensible in that sense. With this fundamental principles in mind, let's look at how to design a solution like this, what can be a possible architecture or a design for this platform, if I can say so. So what I'm going to show right now is a very high-level kind of design and architecture that I have in mind. There are various kind of variations that can be used, but the core remains the same. So this architecture that I'm going to showcase is based on certain segregations that we see as part of this solution, and those segregation we call it interfaces. So I'm going to first tell you what are the different interfaces that we require in this kind of platform, and then you will see a holistic view of the overall architecture and design. So the first component of a platform like this is, we call it tool interface. And this tool interface is basically an abstraction layer between the solution and the various tools. So as you can see, there are tools at the top layer, and then these are solution components. And then in the middle lies this interface, which integrates the tool and the solution components. This tool interface can be designed by technologies like web services or RMI or COM, because you need to pass on commands from your solution component to the tools. So you can use technologies like web service calls, RMI or COM. Now, as you can see this diagram, I have mentioned few components which are core to this solution. And if I can draw an analogy, these components are like minds in human body. So if I have to take a decision, my mind has to take a decision. It takes the decision based on the information stored within my memory. So these components that you see here are basically the information repository for this whole platform. So let's talk each of the component one by one quickly. So the first is GUI control definition. As we all know, each automation tool has its own methodology defined to identify objects uniquely in the application. So a GUI control definition is basically a mapping list of all possible objects and its associated set of standard attributes. So we know that if there is a button object, there are certain sets of properties that needs to be attached with the object. So this control definition will have list of all possible type of objects, and for each object, what are the different kind of attributes that that needs to be captured. So that's definition can be stored either in form of XML or in form of database, but this components has all the definitions, should have all the definitions in place, and you also need to take care of what are different tools that you are integrating, and you should have a comprehensive list of all the controls that are supported by all the tools. So that's the first component. Second is the execution definition. Again, each automation tool differs in their methodology of executing these scripts. So for example, Selenium inject JavaScript in the web application for execution purpose, while Water creates a object of the browser. There are some tools which work on the basis of COM. To add to the complexity, each automation tool understands different language. So Selenium understands Java, Ruby, C#, while Water only understands Ruby. If you are integrating any other commercial tool, then they understand different languages, and so on and so forth. So to standardize this wide variety of execution definition, this component is required. What happens is each tool, be it Selenium or Water, has a way of executing, understanding a command and then executing that particular command. So this execution definition engine has to have all the possible execution interfaces for all the tools that you are integrating. So moving to the next component, which is keyword definition, the third one. So each automation tool has list of actions that can be performed, and by actions I mean actions like click, actions like verify, right? So all these actions, there are certain generic actions which are common across different tools, and there could be some specific action with respect to a specialized tool. For example, if you're talking about mobile, you are integrating a mobile tool, then pinch to zoom is a specific action that can only be performed with a mobile application or mobile tool. So there are certain generic actions, and then there are certain tool-specific actions. So all those action definitions have to be part of this keyword definition component. While the implementation of the function can differ across the tools, but there has to be a generic definition available within this component. And finally, as far as the tool interface layer is concerned, the last component is exception handling. So this any platform or solution like this need to have a standardized and scalable exception handling scenario which can work on multiple tools. This can be easily achieved by standardizing the return codes of the keywords that you are going to create for all the actions. With this, I'll move on to next interface, which is authoring interface. Now, this authoring interface basically is based on the fundamental principle that we discussed, is based on end user abstraction principle. And how do we achieve this end user abstraction? Again, by having few components. And as you can see in the diagram, there are three components: common object repository, common keyword repository, and a test data repository. So if you look at common object repository, based on what we had defined or what you have defined in the GUI control definition component in the tool interface layer, the common object repository will capture that information and store it at a common place in form of a object repository file when you are creating your test case. So for any of the tool that you might have integrated in the backend, the repository is common and in a standard format. So that's one of the key to have end user abstraction. The second is common keyword repository. So from the keyword definition file, the keywords will be available as part of a common object repository, common keyword repository, to be used for test case creation. So while you are creating a test case, you should be able to switch between various keywords from various tools without even knowledge of the tool. That can only happen once you have a common keyword repository where all the keywords are available together. You can have segregations just for identification purpose, but they have to be available as part of a common keyword repository. And finally, a common data repository. So common data repository is to store the test data which will be required during the automation execution of a particular test case. The third one, which is one of the most intelligent aspect of this whole platform, is the execution interface. This interface is based on the principle of scalability and adaptability. And this can be achieved by designing this interface and having two separate adapters that you can see in this architecture. So as you can see here, we have a test case adapter and a tool adapter. Now what does test case adapter do? So this particular adapter parses the test scenario. So once you start your execution, the information is sent to this test case adapter, and this test case adapter parses the test case received and sends each keyword to the respective tool adapter. So for example, if you have created a test case where you have keyword of Selenium, then it will be passed to the Selenium tool adapter. If after Selenium keyword, if you have your Sikuli key adapter, then it will be sent to the Sikuli tool adapter. So this test case adapter has the intelligence, and this intelligence comes from the information stored in the execution definition. So by using the execution definition, by using the information stored in execution definition, the test case adapter decides which tool to call, and then the information is passed accordingly. And the tool adapter passes the information or executes the command on the application. The result is passed back to the test case adapter. And then the information, all the information that we have talked about in this design is stored at a common place in form of a DB. You can also use file system, but then file system has its own challenges. So utilizing the concept of DB is much more, gives you much more scalability. So once you have all the information in DB, you can have a reporting interface which allows you to pull a common report together of all the execution that has happened. And since all the information is stored in a common database, one can generate various kind of reports, like comparison reports across various regression executions required for build health check. You can create any kind of report by just writing your own query and then pulling out the data. Having a database gives you a lot more advantages, like it enables multi-user working. So multiple people can work together on this platform while working directly with a tool set like Selenium has its own challenges. Multiple people working together creates redundancy, etc. So those kind of issues also get solved if you have a common database for all the information storage. So let's now look at a real implementation of a solution like this. So we discussed the concepts. What I'm going to showcase now is one of the solutions that we have developed internally, and I'll try to relate to what we discussed so far, all the interfaces that I showcased as part of design and architecture. I'll try to showcase that with an example of a test case that we have created which runs across multiple platforms. Post that, we'll also discuss some of the existing open source solutions which can be utilized for building such kind of solution. But let's start with what we have developed internally. So let me open the solution which we call Opki. So as you can see, it's a tool agnostic test automation platform. So I'm logging into this platform to access my project. Let me open a project which has already been created in this platform. So this is the main interface that you see, and if you try to relate it with the design and the architecture that we discussed, this interface is the authoring interface that we talked about. And as I had mentioned, that authoring interface requires end user abstraction. I'll showcase how that looks like in this particular platform. Now, as you can see, this has a very rich UI, But you can create your own solution in a script-driven format or Excel-driven format. That's your choice. But in the current scenario, it has a very rich UI for making for better usability as far as the end users are concerned. So as you can see in this interface, it has various authoring interface components like test case, which is then object repository, then data repository. All these we discussed as part of our architecture and design. So if I go to test case and expand it here, you can see there are 3 test cases available. One is we have used Picasa application, and Picasa application can be accessed on mobile, web, and through web service. So the same information, so you upload a picture on Picasa through web, you can access it from mobile, you can modify it on mobile, come back and see it on web, and you can also access directly by calling web service which has been exposed by Picasa. So we have taken a scenario where we are accessing a particular image from all 3 platforms. And as you can see, all 3 test cases for 3 different platforms are in one common interface. That's one of the key for the platform or solution to be more adaptable to end users. Now let me just open and show you how a test case looks like. So I have opened the Picasa web test case, and you can see the detail of the test cases here. And if you look at this test case detail, it's nothing but combination of certain keywords, and keywords are basically the actions that you need to perform on the application. So as you can see, the first keyword is open browser, then there is a common function Picasa web login, then there are keywords like click link, then normal click, then there are certain verification keywords like assert text present. So the test case is basically a combination of various keywords which are available in the repository. Let me show you the common keyword repository that I was talking about. Let me add a new step to this test case. Now I'm trying to add a new step, and here either I can add a step from the function library, but I'll not go into detail of it. I want to showcase the common repository, keyword repository that I talked about. So you see here there are different segregations that we have done just for ease of use purpose. So in the OPKey generic keyword list, we have list of all the keywords. We have put a list of all the keywords that user will require to perform any kind of operation. So whatever step that you need to perform, it's most likely that you'll find a right keyword available in the repository. And if it's not there, it has to be added as part of the execution definition that we, keyword definition that we talked about. So there are various kind of keywords like generic, system, control flow. And there are also some tool-specific keywords that I talked about. So there are tool-specific keywords like for Sikuli, Robotium, and there will be more once we add more plugins to this solution. Right now, it is using Selenium, Robotium, and Sikuli together. So that's why you see only 3 tabs. And what user just needs to do is to select a keyword from a specific group and then add it as part of the test case. So I can select any of the keyword here. For example, again, I'll select open browser, and it gets added in the list. So that's how you abstract the end user from knowledge of the tool. Here there is no knowledge required of the end tool that you will be running with. You just need to have knowledge of the action that you need to perform and the corresponding keyword that you need to add. Similarly, if you look at the mobile test case, the process is exactly the same. Since we are using some tool specific keywords, so you will see some different set of keywords here, but then there are a lot of keywords which are common. Click on button, you'll find it even in the web case. So creation of test case, be it web or mobile, has the same process. You are using the same interface. You have complete abstraction from the tool at the back end. Moving on quickly to the object repository part. As you can see, in the same interface, we have the object repository for mobile and web in a common structure. So user need not know how to fetch repository from Robotium or Appium. The platform itself, based on the GUI definition, captures the object repository when you are working on the application. Then you have common data repository. So you have Excel-like interface where you can provide the data to be used as part of your execution. I'll not go into much detail of this. Let me show you how do we then integrate it as part of one end-to-end flow. So within a suite, or you can also add it as part of your test case. But here, the 3 test cases that we just saw has been added as part of a suite to create an end-to-end flow. So it starts from web to REST, and it goes to mobile. And that's how you perform your multi-platform executions. Let me show you quickly the execution interface that I was talking about. So once you start your execution, I'm sorry, the agent is down, but I'll quickly explain it. What you need to do is to just select the plugin, and you can select, if this drop down is currently not working because the agent is down, but if the agent was up, you will see the list of plugins, which means the tools. So as you can see, we have Robotium, Selenium WebDriver, Sikuli currently installed here. So you can select which generic plugin that you want to run with. It can be Selenium, it can be Sahi, or it can be Water, etc. But the specialized keywords like Sikuli and all will be decided on runtime. So this way, user just needs to select the generic plugin, and the rest of the decision is taken care at the runtime by the platform itself. Once the execution is complete, as part of the reporting interface, you have one common place to access all the results. So as you can see, this is one of the results from the automation run, and this is the result of the end-to-end flow. So end-to-end flow status is there, and then the individual component status is there. You can expand and see the detail at each step with all the information related to that particular step. You can also see the snapshot of each of the steps that was taken during the execution. So the point is, you have a common place to have reporting coming from all the tools and accessible in a standard structured format, so that user is not looking at individual tool and trying to figure out what happened, whether the test case passed, failed, etc. You have just one common place. You can drill down and figure out what exactly was the result. So we talked about the authoring interface. We talked about the execution interface. The tool interface is basically the internal logic, which you cannot see on the UI, and it also has a backend database that we discussed, from where all the information is being pulled and shown on the UI. So it gives you a sense of how a solution like this can look like. But as I said earlier, designing a UI-based such rich solution might be a long process and will require a lot of investment. So You can also create this kind of solution purely based on script in form of a script-driven framework or Excel-driven framework. That will be much faster for you to create. So with this, I'll move back to the presentation. And let's look at some of the existing solution. And the question is, can we leverage something which is existing in the open source world? So there are quite a few solutions, but few solutions to be noted are, the first one is STAF, Software Testing Acceptance Framework. Oh, sorry, Software Testing Automation Framework. And you can access it from staff.sourceforge.net. It has a very good capability of reusable components. There are, as I said, a lot of keyword repositories are available. It does not integrate currently multiple tools, but it's quite extensible. You can download the code and build your solution on top of it to integrate multiple. So it could be one good starting point for building a solution like this. There is another framework which is Robot Framework. It again comes with some very interesting utilities available inside the tool. For example, backend validations. It's extremely good for your backend validation processes like database, file validations, log comparisons, etc. So you can combine Staff with Robot and start building your solution on top of it. That will be it will increase the overall process of creating a solution like this from scratch. As a concluding thought of what we discussed as part of this session, open source world is an excellent place to get specialized tool and capabilities at absolutely no price. And the way innovation is happening, open source world is a place to be. But it throws challenges, it throws multiple challenges in terms of managing multiple tools, skill sets, etc. But the way applications are growing, the way complexities are growing, leveraging best of the capabilities are the way to go, as far as I have understood so far based on my experiences. There cannot be a monolith tool which supports everything. You always have to look for specialized capabilities, and then you need to have a solution, or you need to invest in solution from future perspective, using which you should be able to utilize the best of tools available in the open source world. It's much cheaper than buying a big or doing a huge investment in a commercial tool. Again, those commercial tools have a lot of limitations. There also you at times need to integrate with tools like Sikuli, etc. to get specific capabilities. So if you invest in a right way to build an umbrella solution like the platform that we discussed, which can bring best of tools together, it can be a big future investment as far as test automation is concerned. So with this concluding thought, I'll open the session for question and answer. And thanks for attending this session. So I'll try to answer most of the questions, but if due to time limitations we are not able to answer all, I'll mail answer of the questions to the individuals who have posted it. So the first question is, what is the productivity of test case creation using Opni? It has been posted by Jyoti Mahendra. So it varies from platform to platform, and also it varies from complexity. It depends on complexity of test case, complexity of application. But our experience says, and we have data to prove, that the productivity is much faster than the core tool if I compare it with the core tool. So if I'm using core Selenium, I can automate for sure 30% faster with the use of OpKey or any solution like OpKey. Second question from Jyoti Mahendra is, what is the ramp-up time when a new manual QA wants to start writing test cases using OpKey? So one of the advantage and the core principle that I was talking about is tool abstraction. So because of that, the ramp-up time is very quick, and my experience says that within a day or maximum 2 days, a manual QA can start writing a test case within OpKey. So the next question is from Shashank Gopannagiri. By using OpKey, we can test mobile web REST. Answer is yes. You can test these platforms individually, or you can club them together, and you can also automate desktops by using AutoIt. Though this session was not for commercial tool, but those also can be integrated if the need be. Next question is from where can we download this tool? So you can go to our website opkey.crestekglobal.com. You can go get more information about the product, and the download is also available. The next question is from Sridhar Shivakumar. Can the evidences snapshot be exported? Yes. You can export it into various forms, HTML, PDFs. We also have a facility to send the report on email as soon as the execution is complete. There are various abstractions available in terms of summary, detail, executive, etc. Those kind of reports can be generated. There is another question from Praveen Kumar. Please suggest if this solution is being implemented commercially for any client. Yes. So you can directly contact us. We can let you know more details about it. We can give you case studies and more facts about the tool. There is another question from Jacob T. Paul. Is it possible to test big applications like hospital management? Of course, yes, Jacob. We have tested. We have used OpKey to even automate enterprise applications from banking domain, from telecom domain. I don't see any reason why a hospital management application cannot be automated. There is another question from Ankit. Does OpKey has an XML API for further integration with my firm's native reporting tool? Yes, we do have open APIs which can be used to integrate more tools, be it your native or some of the existing open source or commercial tools. So this was one of the core principles with which OpKey has been designed, that it has to be scalable, extensible. So yes, it can be done. Another question from Srikant. How can we integrate it with CI? So Srikant, we have a direct integration with Jenkins, Hudson, and Bamboo. So there is another question from Praveen. Is it possible to automate app like Siebel, SAP with high interactive UI? Yes, Praveen, but in that case you'll have to use, so the problem is Selenium, any open source tool like Selenium or Sahi cannot automate Siebel SAP. But in that case you can use tools, commercial tools like QTP or Test Complete with in integration with OpKey to automate it. And we have by default plugins available for those tools as well. There is a question from Ashok Tambe. Is OpKey free to use and scale? So there is a version which is available free, which has certain limited capabilities, but again, it's quite exhaustive for a small scale project. But if you are looking at a big project, we have various editions available which are license based, pretty competitive rates. So those details can be accessed from the website. You can post a query and we can provide you that information. There is another question from Amol. Does OpKey automate for WPF Smart application or suggest any open source for WPF Smart application client server based? So unfortunately, in open source world, there is no good tool available for WPF application, but OpKey with a tool like Test Complete or QTP can be a right fit. There is a question from Srikant. Do we need separate environment to test different browser versions? I'm not very clear about the question, so maybe we can interact over email and I can answer you the question. So considering the time limit, I would like to close the session for today. I'll get the log of all the questions that has been posted, and if I have missed something, I'll respond to the individual with answer of that question. And feel free to post more questions on the web page. I'll be looking at the web page and will be happy to answer any more questions around the current session.
Well,
thank you so much.
Thank you so much, Avinash, for answering the questions. Thanks for the insightful presentation. It was a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of this session would be available on techgeek.com by evening. Thank you all. Have a great day.